Hi everyone, I'm Daniil. I am open source engineer in Veeam Kasten. So Veeam and Kasten are doing backup and restore, data protection. And today I want to talk about our open source project, which is now a CNCF Sandbox project Kanister, which is essentially a component for your application consistent backups, which makes it more cloud native friendly to do backups. So why backups for Kubernetes, right? Everything is stateless. We don't have any state, but in reality, Kubernetes is a state, right? All the workloads could be scalable, right? You could scale them down and scale them up, but you still have configurations. You still have the actual stateful workloads. And according to CNCF study, this is 2020, but then was another one in 2022. People run databases in Kubernetes. People run stateful workloads in Kubernetes, and we need to protect those. GitOps is great, but well, you don't really save your data when you do restore with GitOps. And also, how many people here actually back up your Git repository? Yeah, you probably should do that as well. And finally, cloud providers might host your actual databases, but they also tell that, oh, you need to save your snapshots if you do like RDS or other databases, right? They explicitly tell you that do not trust them to store your data. So that all great. Kubernetes having great story for adoption. This is 2022 report. So the more applications adopt Kubernetes, the more data we have there. Data services, volumes, actual databases. We have now cloud native operators for data services and so on. And further we go, more data services we have, and we need something to organize all these backups. And this is another piece of this report. This is from Datadog. What kind of applications do we run in containers? And yeah, there's a lot of Nginxes, but almost everything else is hosting some sort of data. And finally, this is a piece of advice. It's a 3-to-1 rule, that you do need to ship your data somewhere, you do need to replicate it somewhere, and you do need to ship it offsite, preferably at least once for your critical data, preferably more than once. And there are certain challenges which are amplified by the fact that we go on cloud native, that we're using Kubernetes, such as we might have multiple domains and with microservices even more. We might have many different data services in our clusters because it's so easy to do them, right? It's so easy to spin up new application which is using a new data service. We have all kinds of different ways to back up our data. We could have volume snapshot, we could have some provider-specific APIs, we could have some logical backups as well. So essentially, there's a lot of things to consider when you writing your backup scripts, essentially. And even now, people are writing backup scripts in order to orchestrate all of this. On top of that, we might also consider, should we scale down our application before we backing up? Should we save into S3? Should we save into maybe our enterprise has a subscription to some data storage in which we need to save our data? So this is another concern that you have to take into account. This is roughly what we've seen in Kasten on how people use data services in Kubernetes. These are 3 examples, but essentially all of them mix and match. So example number 1 here is that you have some RDS or SQL server in Azure, and your Kubernetes workloads using that. Another example being that you have your Kubernetes workloads for your applications, but you also have another Kubernetes, let's say, namespace or a cluster, which runs your data. And the third example is when you actually collocate in your namespace, you might have your namespace which has both workloads and the data. And then in reality, what people end up using is all of 3 in the same setup. So that's another layer of complexity for your backup scripts to actually, well, how do you orchestrate all of this? Right, and then there's another layer here, just to mention that what do we mean by application consistency or application-centric data management is that when you are DevOps, right, when you designing your applications, when you're designing your workloads, what you care about is that your application can recover. And the recovering your disk or you're recovering your like database is good, but what you actually want to get back when you recover is your application and all the data in there, which could be multiple data services, multiple storages, that is all in consistent state, which means that in order to back it up, you also need to come from your application point of view, from your workload point of view, rather than your data storage point of view. And Kanister is now Sandbox project in CNCF. We've been working on it for quite a while, and what it's providing is essentially an orchestration of a backup and restore operations, not taking into account things like scheduling or policies. This is data application consistency focus, and we focus very heavily on capturing the data, orchestrating your workload, not orchestrating, sorry, how to say that, capturing what your workload needs to back up, and shipping it to the place where you need to store it. We have a bunch of community blueprints, so we have support for multiple data services out there, and this is a short story of how we get there. Currently in Sandbox, going further in the CNCF, keep going. So how do we do that, and how do we do that in cloud native way? What's important? So we provide several custom resource definitions, and essentially what Kanister is a controller which manages this custom resource definitions. The blueprint is how do you back up your workload. So this is a custom resource definition which describes which steps need to be taken to back up or restore your workload. And it's essentially a template. Then action set is essentially a command to perform an action based on a blueprint. So it fills your template with the actual data. And finally, profile, it tells you where to store your data. It points to a particular S3 bucket or Google storage or some vendor-specific stuff if it's implemented. So this is roughly how an operation would run. So user would create an action set which then reference blueprint Kanister controller would pick it up, run certain operations in pod, most likely, or multiple pods, and perform some backup, let's say, for the MySQL here. And then it will save this data that it captured into a destination that it's pointed out by the profile. And then finally, action set captures the status of the operation. Pretty straightforward, super simple. On the runtime, it's pretty straightforward. So the most important part of how you would interact with Kanister is the blueprint. And the blueprint describes, it's a custom resource, again, cloud native way. And it describes how to perform a backup or restore operations. You would create it in your Kubernetes cluster, you store it in there. You might create it in your GitOps, you save it somewhere in the repository, so you can always recover it. This is roughly what Blueprint looks like. So it has actions such as backup, restore, delete. Each action has phases, one or many, and each phase executes a function, and functions are provided by Kanister. Most typical functions mentioned here are specific to RDS, because I was going to do RDS demo if I have time. But actions, a lot of actions are just spin up a pod and run a command in there, which is how you can relatively easily design your own blueprints, because you spin up a pod, you run a command, whatever you need to save is going to be there. But also some actions specific for PVCs, there's some actions specific for RDS in this case, some functions specific to RDS. And then your action set is actually data for your blueprint, right? So it tells what do you need to back up and where do you need to back it up to. So it references the profile, it references the blueprint, and it fills up data for the blueprint. So if you go back for a second, you see there's some template variables, which could be communication between the phases, but they could also come from your action set. Essentially, your action set fills in the template variables. And finally, action set, when you execute it, when you create it, the Kanister will execute it, and it will track the progress of your action. So here we have a complete action, with a state complete. We have the phases listed there. So it created a snapshot. It has outputs for this create snapshot. So this is what you get from this action set, and that stays essentially as long as custom resource stays there. That stays in your Kubernetes. And I will try to run the demo for the RDS backup. So I think we still have time. Yep. Yeah, it's been super fast. Okay. Yeah, I'll try to run it from a separate window if I could. Can you see that? Oh, nice. Right, so I'll be pausing and playing again. Hopefully you can see what's there. Essentially, this is the. Oh, let me just quickly switch to the presentation, just for the next slide. This is roughly how the setup looks like. What I'm trying to back up here. So we have some sort of database client like your application, which is using RDS, and we want to do the application consistent or application aware, in this case, backup to the S3 bucket, which might be outside of your account on AWS, or It doesn't have to be S3 bucket. Just for the purpose of the demo, it is S3, but it could be some Google storage or Azure storage. So what we're gonna do, we're gonna set up Kanister in this Kubernetes cluster, and we're gonna run the blueprint to actually perform an action. So let's go back to the video. I have recording, so sorry for that. No live demos today. So here what we have, there's a RDS instance, there's a Kubernetes cluster, there's essentially a deployment which acts as a client for a database. In this case, it's just Postgres client, but it would be your application actually. And finally, we have the S3 bucket in which we're gonna save stuff. Currently nothing there. So when we start, yeah, we need some data. Here I'm just creating some simple database to just fill it up with something, with some data there. There's a simple table that's pretty straightforward data setup. So we have some data, we have some cute pets in our database. We don't want to lose them. So yeah, here they are. Now, in order to protect our application, what we want to do is we want to set up Kanister. So Kanister setup is pretty straightforward. All you need to do is to get a Helm chart, install Helm release in your cluster. Here we create a new namespace for it even. That's relatively fast. Here it is. We have Kanister, and it's even running right away. And what Kanister provides is this three main customer source definitions that I mentioned: blueprint, action set, and profile. There's another one. We're not talking about this one, but we're going to be creating blueprints, profiles, and action sets in this demo. Then what I'm getting here is an example blueprint from our examples in GitHub. Ideally, you would want to download the blueprint and edit it for your workload, but this is just a simple workload. That's why I'm using example blueprint. So I'm just grabbing it directly from Git in this case. And yeah, this is our blueprint, customer source definition. Here I'm just going to check that it's there. Yeah, we get a blueprint which describes how to perform a backup. And thanks to the fact that they are templates, they are reusable to a certain extent. So I'm using here an example blueprint. You probably will edit it, but again, you might be able to reuse it for, let's say, different clusters, for different workloads, if they have the same process of backup and restore. Here I'm creating a profile which points to a particular bucket in S3. You can ignore the access key, it's no longer valid. Yeah, so profile ID, I will need that just to create an action set. I will just reference a profile. That's why I'm saving it here.
Connection between Kanister and the database is written there in YAML, or how is that?
Right, and that depends on the blueprint, right? So in this particular case, what we do is we use the AWS APIs in order to instruct AWS to create a snapshot. So we instruct RDS to create a snapshot. We could use config maps in order to make a connection to, let's say, Postgres. We could use anything, really. So it just depends on, it's very extensible. The blueprints are very extensible. What they can reference secrets, they can reference config maps. So if you have a way to access it, we can even embed things like service accounts into the pods that are going to be created for backup. So you can authenticate with service accounts if you need to. So blueprints, by being templates and by allowing us to just put commands in there, like not in this demo, but in general, you can put shell commands in there. This allows you to basically do anything, as long as the infrastructure provides it, as long as you can express it in config maps and secrets and things like that.
And then Kanister and this S3 bucket connection between that also we have to establish.
Yeah, but the ES3 buckets are addressed using the profiles. So profile would have a secret, would have a reference to a secret. Sorry, I can't live check things. But profile would have a reference to a secret. Secret will contain credentials to your S3 bucket, and that's how it saves into S3. But again, it doesn't have to be S3. That could be other service providers. So let's keep going. Yeah, so here's our action set to save our data, to back up our data. I'm using here a tool called CNCF, which are a tool which, what it does is just creates custom resource definitions with a bit of syntax sugar for command line. You could do that with just YAML. I'm just using CNCF here because it's more convenient. So here I'm referencing the blueprint, I'm referencing the profile, and I'm referencing the action that needs to be performed. Also anchoring it on the config map, which contains database config. Again, this could be referencing deployment as well if you need to do something with deployment in your blueprint. And it's gonna run. Sorry for my editing. So this creates a backup action set, which is now executing. The controller hopefully picked it up and started executing it. And I'm going to show in a second, I'm going to show what it does there. Another convenience of CNCF is that it generates the dynamic name for your backups. So here I'm just going to watch the execution. There's some editing there because operation of exporting RDS snapshot into S3 takes some time, but here it doesn't because I'm editing it. So here you can see the status of all the phases. You see that create snapshot phase is complete, and the export snapshot phase is running. Each phase has its own output artifacts. They will be populated when everything's finished. There's some execution I'm watching on here. Is the export snapshot running, and when everything is complete, sorry for the controls here. When everything is complete, the whole action set will be set as complete. You can grab it. I'm currently showing the YAML, but in a short format, it's just going to say complete. Essentially, you can then take the artifacts from this backup, and they will point to either snapshots or tarballs or other artifacts created by the blueprint during this operation. So also in the spec you can see this is just references. The blueprint. It references profile. It could be just created with YAML. I'm just using CLI here. Now I have 5 minutes, so I'm not going to be pausing that much. Here's the tarball that we created. It's in S3. It's not just in RDS.
That's the size 925.
Yeah, because I have just 2 records in the database there. And I'm checking the database. Yeah, here I'm just going to drop the table. Here we have paths, and then we're going to drop the table, and we not have them anymore. And we need to recover at this point. So in order to recover, I'm using the CNCF again in order to create a custom resource definition from existing backup. This is again for convenience because you need to fill in all the input artifacts. You need to fill in what blueprint was used, and in this case, all this information is in backup action set, so we're just going to use it as a source for a restore action set. Again, for convenience, technically doable with YAML, but why do that if you can use a script? And the restore action set is actually doesn't require much editing. It's gonna be done, I think, right away. Here I'm watching it. It's already complete. I'm going to show what it looks like. As you can see, it references the artifacts from the source action set, references the same blueprint, and it shows the status of all the steps that were executed as complete. I'm showing that it's using the artifacts. Yeah, sorry for my editing again. We'll also have timestamps for everything, for every stage, every phase, and status for them. If they fail, they would have errors. These ones don't. And finally, going into our database, just checking that our data is there, which is, yeah, that's what expected. So finally, do I have something else? Yeah, so what do we have is we have a backup action set, we have a restore back action set, which also references by name the backup action set. So we now have this information recorded in our Kubernetes. Right, so going back to presentation, what we just, are you gonna play the video? What? Okay, so what we just did is we took a RDS snapshot, we shipped it into S3. All the operations were running in Kubernetes runners, right, in the pods. We store all of our blueprints in Kubernetes. We can save them in Git if we need to. We have all the backups metadata. We have all the action sets in our Kubernetes listing when the backup was taken, what kind of blueprint it was using. So we have both the blueprints are in our library. We know what they are. We know how we back up and restore all the operation, all the data services that we have. And we have all the actual actions of backup and restore also in our Kubernetes. So that makes it super easy to know, like, when did you take a backup? what was the result, where the artifacts for all the things in the same place in Kubernetes, essentially. And right. And finally, there's some things which we currently support in Kanister, like kubexec, kubetask, are what I mentioned when you run a command in a pod. We have some specific like lifecycle functions. We have PVC functions. I just save a PVC somewhere. We have the RDS. We have support for multiple destinations. And yeah, this is an open source product. So if something is missing here, please tell us. Or maybe contribute if you can. Finally, there's some links on the project itself and GitHub and Slack and so on. So please help us make it happen.